Hi friends, welcome all of you on the another lecture of the RCC, the lecture 4th. In this lecture, we are going to study about the characteristic compressive strength of the concrete. Okay, so the lecture 4th, lecture 4, RCC. We are going to study about the characteristic strength. Our topic is characteristic characteristic strength of concrete. Characteristic strength of concrete. We are going to study about the characteristic strength of the concrete, FCK. So what is the characteristic strength of the concrete? ये वो स्ट्रेंथ होती है जो सपोज हमने 100 क्यूब टेस्ट किए, उन 100 क्यूब में से 5% तक 5% से कम वाली, ये 5% और 5% से नीचे की जो स्ट्रेंथ होती है टेस्ट रिजल्ट्स में, उस स्ट्रेंथ को, ऐसी स्ट्रेंथ जिससे 5% रिजल्ट कम हो, उस स्ट्रेंथ को हम कैरेक्टरिस्टिक कंप्रेसिव स्ट्रेंथ कहते हैं. वंस मोर आई मैन एक्सप्लेन यू. लेट अस सपोज हमने 100 क्यूब टेस्ट किए, उन 100 क्यूब में से ऐसी स्ट्रेंथ जिस स्ट्रेंथ से 5% क्यूब के टेस्ट रिजल्ट हो वो कम हो, उस स्ट्रेंथ को हम कैरेक्टरिस्टिक कंप्रेसिव स्ट्रेंथ कहेंगे कंक्रीट की. So let me explain you in English as well. So what is the characteristic compressive strength? It is the strength below which not more than 5% of the test result are expected to fall. Such a result is called characteristic compressive strength of the cube. So whatever point I have discussed, let me write it. So the, it is the strength below which not more than 5% of the test result of the not more than 5% of the test result test sorry not more than 5% of the test result are expected to fall. That means it is the strength below which not more than 5% of the test result are expected to fall. Such a strength is called characteristic compressive strength of concrete. Such a strength is called characteristic compressive strength of the cube. And another point, the concrete is designated by the characteristic compressive strength of concrete at the age of 28 days. मीन्स कंक्रीट को जो हम रिप्रेजेंट करते हैं वो कैरेक्टरिस्टिक कंप्रेसिव स्ट्रेंथ के रूप में करते हैं जो 28 डेज के रिजल्ट पर हमको जो प्राप्त होती है. दैट मीन्स कंक्रीट इज डेजिग्नेटेड by the characteristic compressive strength of concrete at the age of 28 days. Let me write this point also. So, concrete is designated by characteristics compressive strength of concrete at the age of 28 days. Okay, एंड ये जो कैरेक्टरिस्टिक कंप्रेसिव स्ट्रेंथ होती है ये 5 के मल्टीपल में होती है, जैसे M5, M10, M20, M25, M30, M35, M40, M45, M50, M55, M60, M65 and like this. So let me write here one more point. Generally, mostly the FCK means characteristic compressive strength of the concrete is represent in the multiple of 5. Let me add the page. And its unit is Newton per mm square or MPa megapascal. Newton per mm square. So this is the strength which we get by the cube test, and below this strength 5% results are expected to the fall. Suppose, let me explain by the example. Let us suppose we take the 100 cubes, 10.5 newtons per mm square, this is strength. Another cube is 22 newton per mm square, whatever the strength getting, 25, 26, 21, 27, 29, 30, like this. ऐसे हमने 100 क्यूब टेस्ट किए. लाइक दिस वी हैव टेस्टेड द 100 क्यूब्स. सो हमारा कैरेक्टरिस्टिक कंप्रेसिव स्ट्रेंथ की डेफिनेशन ये कहती है कि वो टेस्ट रिजल्ट जिससे 5% रिजल्ट एक्सपेक्टेड टू द फॉल, 5% रिजल्ट कम हो. तो यहाँ पर हमारी कौन सी स्ट्रेंथ है? 1%, 2%, 3%, 4%, 5%. मतलब ये जो स्ट्रेंथ है हमारे छठे नंबर की इन इंक्रीजिंग ऑर्डर में कंसेक्यूटिव, ये जो है ये ही हमारी FCK है. एट द एज ऑफ 28 डेज में। ये स्ट्रेंथ है। हमने 100 क्यूब टेस्ट किए, जिसमें से छठे नंबर पर इंक्रीजिंग ऑर्डर में जो भी स्ट्रेंथ आती है वो हमारी एफसी की स्ट्रेंथ होती है। ओके, so in increasing order, the fifth number out of the 100 cube tested, the results of the sixth cube in increasing order, this strength is called the FCK. So this is the characteristic FCK. But here हम इसको रिप्रेजेंट कैसे करेंगे? हम इसको रिप्रेजेंट कैसे करेंगे? हमने कहा कि द कैरेक्टरिस्टिक कंप्रेसिव स्ट्रेंथ जो होती है ये 5 के मल्टीपल में होती है। वी नो दैट द कैरेक्टरिस्टिक कंप्रेसिव स्ट्रेंथ इज द मल्टीपल ऑफ द 5। सो ये आइदर द 20 हो सकता है, 25 हो सकता है, या 30, 35 और 15 like this. So here this strength will be, this is the more than 20, 1, 2, 3, 25, बट 5-25 को हम नहीं ले सकते क्योंकि इससे नीचे सिर्फ 2% ही रिजल्ट है हमारा। हमारी डेफिनेशन ये कहती है कि 5% होना चाहिए, उससे नीचे, उस स्ट्रेंथ से नीचे 5% रिजल्ट होने चाहिए। ऐसी स्ट्रेंथ जिससे नीचे 5% स्ट्रेंथ हो। यहाँ पर 25 फिर 21, तो 21 तक में यहाँ पर दे 29। हम 30 को नहीं ले सकते। क्यों नहीं ले सकते? क्योंकि 30 को अगर लेंगे तो इस स्ट्रेंथ से नीचे हमारे 6 रिजल्ट हो जाएंगे, फर्स्ट, सेकंड, थर्ड, फोर्थ, फिफ्थ एंड सिक्स, तो 6% हो जाएगा। एंड हमारी डेफिनेशन सिर्फ 5% के लिए वैलिड है। हमारी डेफिनेशन बोलती है कि दिस इज द 5% बिलो द टेस्ट रिजल्ट, दैट इज कॉल्ड द कैरेक्टरिस्टिक कंप्रेसिव स्ट्रेंथ। तो हम क्या करेंगे कि 5 का मल्टीपल यहाँ पर क्या है, हम ले लेंगे 20। 25 नहीं ले सकते क्योंकि 25 से नीचे भी इधर स्ट्रेंथ है, तो हम 20 ले लेंगे। और जो 20 होगा 20 न्यूटन पर एम स्क्वायर, ये कितना होता है? इससे कम होता है, 5% से कम। और इसका मतलब इससे नीचे कितने रिजल्ट है? 0। और 0 जो है ये 5% से कम है, 5% से कम है। इसीलिए हमारा कैरेक्टरिस्टिक कंप्रेसिव स्ट्रेंथ जो होगी कंक्रीट की, ये M20 न्यूटन पर एम स्क्वायर होगी। और इस कंक्रीट को हम डेजिग्नेटेड जो करेंगे एम इसको हम करेंगे M20 से। दिस इज द our strength. So I hope that you are understand very well. I hope that you are understand very well. Now let me explain it in English also. So if we tested the 100 cubes and in increasing order, the sixth number strength is called our characteristic compressive strength, and this characteristic compressive strength is the multiple of the 5. So here we are not selecting this 30 because of this, below this 30 is the 6% results are, and as per our definition of the characteristic compressive strength, the test result should be below the expected 5%. So we can take here 20 as the our FCK, and below this 20 is 0%, and the 0 is the less than 5%. So our strength will become this 20 Newton per mm square, and this strength is designated as the, we now the characteristic compressive strength is designated the concrete. So M20 is designated the concrete as M20, and the unit is Newton per mm square. I hope everything is clear. Let's go on the next. Let me add the next page. Another, so if we draw this test result on the histogram, let me draw. Where is this one? So okay. So this is the, we are making there the graph on the histogram, the frequency and the strength graph. So 1 minute. So this is the uh, this 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 graph is not in skill, so don't consider it in skill. I am roughly making it for the understanding point of view. Okay, so here in this y-axis we taking the frequency, so frequency, and on a y x-axis we are taking the strength. So at this frequency at cube tested there is the 10, then 12 and 15s like this. So the result of this sample is 19, 20, 21, 25, 22 and 25, 30 like this in Newton per mm square. So this is the representation of the strength and the frequency of cube in the graphical formation. This graph is now as the histogram. And if there the sample is the 15, but if we increase the indefinite number of the 15s, indefinite number of the samples like the 5,000 or 6,000 or 10,000 or 300,000, then this graph is converted into the frequency distribution curve. This graph is converted into the frequency distribution curve like this. If we increase this graph, so this graph will convert into this. If number of the cube is converted into the frequency distribution curve. Let me draw it again. Another. But here you are looking at one point on the same concrete. At the same concrete, एक जैसे concrete में strength का variation आपको दिख रहा होगा यहाँ पर 9, 20, 21, 22, right, like this. ऐसा क्यों हो रहा है? Why this is happening? It is because that the concrete is non-homogeneous. Our concrete is not an homogeneous, it is non-homogeneous. So the concrete is non-homogeneous. So the strength is varying. So the strength is varies. So the strength is varies. Let me one minute. This is not giving the strength is varying. I hope that are you understand up now. Let me add the one more page. In previous page I have told you that If we increase the number of the sample, then this histogram is converted into the frequency distribution curve. This frequency distribution curve. So let me draw there the frequency distribution curve as well. This graph is not in the scale. I am drawing only let me change the background so it will be more understand for us. Okay. Now, what? 1 minute, wait, please. So there we will drawing the frequency distributions curve like this. This graph is not proper. Let me remove it again. Make like this. This is the frequency distribution curve. This is the frequency distribution curve on this x-axis. So here we are taking the frequency in this side, frequency on the x-axis we are taking the strength in Newton per mm square. So this is the nothing but it is the frequency distribution curve. So for the most of the engineering materials, the frequency distribution curve are same. For the most of the engineering materials, the frequency distribution curve are same. Are same. So that is called the normal distribution curve. This is called the normal distribution curve. By using this normal distribution curve, we can find out. By using this normal distribution curve, we can find out the. By using this normal distribution curve, we can find out the mean, standard deviation, variation itself. So by using this distribution curve, we can find out the mean, standard deviation and the variation itself. Let me add the what is this standard deviation? This standard deviation tells about the quality controls on the site. If the quality control is good on the site, then the value of the standard deviation will be less. And if the quality control is not good on the site, then this standard deviations will be more. We will discuss it in further in a few minutes. Wait. So if you draw this, let me add the one more page here. Okay. If you liking it, please like and subscribe.